Okay. Good morning to all of you. And last class, we will be discussing about applications of derivatives. Before going to one particular type of question that will come for the board exams for 6 marks that we discussed yesterday, but we are going to do more questions of that only. But before that, one concept is remaining in this section. Like f dash x is equal to 0. This was the main two concepts like f dash x derivative is equal to 0. F dash x is equal to 0 मतलब there are 4 situations मैंने बताया आपको जैसे f of x function में भी है function में भी f of x में भी constant f of x may be constant. Second option, at x is equal to c, f dash c is equal to f dash c is equal to c. एक particular point में derivative 0 मतलब may be a constant. At x is equal to c, local maxima, नहीं तो at x is equal to c, local minima, or one more option, x is equal to c is point of inflection. This is one of the important thing in this chapter. F dash x is equal to 0 मतलब there are 4 different options. Function may be a constant, नहीं तो उस point में function को local maximum होगा, local minimum होगा, or that point may be a point of inflection. That means it's just changing its concavity. Then another thing मैंने बोला था critical point. Critical points मतलब points where f dash x derivative is equal to 0 or undefined. These kind of points are known as critical points. Critical points बोलते हैं. And if a function has a maximum, if a function has a maximum or minimum, maximum or minimum है तो that will be at the critical point. That will be at the critical point. Function के लिए कोई maximum और minimum है तो critical point में ही होगा. ठीक है? If the function will have a maximum or minimum, that will be at the critical points only. And initially we have seen one thing, like a function may have maximum value, may have minimum value, may have both maximum and minimum. Sometimes no maximum, no minimum. ये हमने देखा था. कोई भी फंक्शन है तो उसके लिए हो सकता है मैक्सिमम वैल्यू होगा, मिनिमम नहीं होगा, मिनिमम होगा, मैक्सिमम नहीं होगा. कभी कभी दोनों एक्सिस्ट करते हैं, मैक्सिमम और मिनिमम एक्सिस्ट करते हैं. समटाइम्स मैक्सिमम भी नहीं होगा, मिनिमम भी नहीं होगा. Here I want to tell you one particular point. If it is a continuous function मतलब without any break, continuous function, if it is a continuous function in the closed interval, then f has absolute maximum value and f attains at least once, and also f has absolute minimum value. Means closed interval में फंक्शन के लिए मैक्सिमम वैल्यू भी होगा, मिनिमम वैल्यू भी होगा. इट्स मीनिंग in a closed interval, in a closed interval, function will have 100% will have a maximum and minimum value. Do you know why? In a closed interval, the function will have a maximum and minimum value. If it is a continuous function होना चाहिए. If it is a continuous function, then the function will have a maximum and minimum. Do you know why? Anybody? You can tell what is the reason? Normally, we know that for a particular function, there are 4 different options. Sometimes function will have maximum value, but there won't be any minimum value. Sometimes minimum value exists, but maximum value does not exist. Sometimes both maximum and minimum exist. Sometimes there won't be any maximum or minimum. But this theorem says for a continuous function in a closed interval, for a continuous function in a closed interval, not for other functions, for a continuous function. If the function is continuous, for a continuous function in a closed interval, the function will have a maximum and 100% there will be a maximum and minimum. Can you tell me the logic behind that? Anybody? Anybody? Sanket, Satpute, कोई भी, Vaishnav, Omkar. Can anybody tell what is the reason or what is the logic behind this? नॉर्मल केस में हमें पता है कि कभी कभी मैक्सिमम रहते हैं, मिनिमम नहीं रहते, कभी मिनिमम रहते हैं, मैक्सिमम नहीं रहते, कभी दोनों रहते, कभी दोनों नहीं रहते. बट क्लोज इंटरवल है तो देयर विल बी.
सर कुछ
क्या बोलो?
डिफरेंशिएबिलिटी का कुछ तो है सर.
लाइक सिंपल लॉजिक, लाइक देखो फंक्शन, देखो मे बी द ग्राफ इज लाइक दिस एनीवे. Maybe the graph is going like this. Okay. So normally ये कहेंगे फंक्शन के लिए कोई मिनिमम भी नहीं, मैक्सिमम भी नहीं, क्योंकि राइट साइड में इट्स गोइंग अप, लेफ्ट साइड में इट इज गोइंग डाउन, बट इट इज कंटिन्यूअस है. बट उन्होंने एक पर्टिकुलर इंटरवल बोला. इंटरवल है तो रेस्ट्रिक्टेड हो गया ना, लाइक सम ए टू बी, मे बी फ्रॉम हियर, लाइक दिस इज ए टू, मान लीजिए हियर बी, एक पर्टिकुलर जगह बोल दिया ए टू बी. सो नाउ देखो ग्राफ का पोर्शन आएगा, रेस्ट्रिक्टेड पोर्शन ही आएगा ना, लाइक कितना एरिया आएगा. सो इट विल बी लाइक एरिया ऑफ द ग्राफ इज ओनली अप टू, we are bothering about only this much here. This red wala portion. See, so when it is defined in a closed interval, we are discussing about a closed interval AB. That means A is also included, B is, A is, that point is also included, A is included. So that point is there in the graph. Here also this end point is there in the graph. So then only this much area, starting from here, only that much area. सो उससे दैट मच एरिया तो फंक्शन के लिए मैक्सिमम एंड मिनिमम होगा ना, isn't it? Did you understand?
Yes, sir.
क्योंकि it's just saying about a particular interval a to b. So a to b मतलब graph only one particular area we are checking, a to b. So in that area, of course, there is one maximum and there is at least one minimum value will be there. Okay.
Yes.
या and अभी वो ऐसे मैक्सिमम और मिनिमम है तो किधर होगा?
सर ग्राफ अगर एक्स एक्सिस को पैरेलल होगा तो
ग्राफ एक्स फिर भी एक्स को पार ले तो भी इंटरवल है ना, जैसे आई विल शो यू
क्यों है ना
लाइक दिस एक्स को पैरेलल मतलब आप आपने बता रहे यही ग्राफ, सपोज दिस इज अ ग्राफ एक्स के लिए पैरेलल, राइट? सो कांस्टेंट फंक्शन, so that also interval like a to b, maybe the okay, this is point a, this is the point b, so your function is from here to here and constant function, so there is as constant function का क्या एक ही वैल्यू रहते हैं ना, f of x is equal to 5, suppose this is y is equal to 5 मतलब y is equal to 5 मतलब there is only one value for this function, so उधर maximum और minimum का क्वेश्चन नहीं आ रहा क्योंकि it is a constant function. Constant function का वैल्यू हमेशा constant ही रहेगा. For example, for this particular function it is always 5. इधर इंटरवल रेस्ट्रिक्ट नहीं किए तो भी there is a maximum value, the maximum value is 5 but there is no minimum value. Understood? But this is a trivial case because either like we can say minimum value is also 5 because 5 से नीचे कोई भी value नहीं and 5 से आगे भी कोई भी value नहीं. So in this particular case, constant function का case में हम बोल सकते हैं minimum value is 5, maximum value is also 5. Is it clear? संकेत?
यस सर
Yeah. कांस्टेंट फंक्शन का केस में दोनों वैल्यू सेम है, मिनिमम वैल्यू भी 5 है, मैक्सिमम वैल्यू भी 5 है क्योंकि 5 से नीचे कोई भी वैल्यू नहीं, सबसे स्मॉलेस्ट वैल्यू 5 है, 5 से आगे भी कोई भी वैल्यू नहीं फंक्शन के लिए, सो क्योंकि सबसे हाईएस्ट वैल्यू भी 5 है. सो इन दैट पर्टिकुलर केस द मिनिमम वैल्यू इज 5 एंड मैक्सिमम वैल्यू इज 5. एंड कमिंग टू दिस सिचुएशन, सो क्लोज्ड इंटरवल में तो फंक्शन के लिए मैक्सिमम होगा मिनिमम होगा पक्का. सो वो कौन सा पॉइंट में हो सकते हैं, कौन सा पॉइंट में हो सकते हैं? देखो मैक्सिमम है तो इधर हमने बोला मैक्सिमम है तो इट विल बी एट क्रिटिकल पॉइंट्स. क्रिटिकल पॉइंट्स मतलब द डेरिवेटिव इज इक्वल टू 0 और अनडिफाइंड. डेरिवेटिव 0 मतलब जब टर्निंग पॉइंट होते हैं उसी पॉइंट में, नहीं तो अनडिफाइंड मतलब शार्प टाइप, जैसे मॉडुलस फंक्शन वी शेप्ड ग्राफ जो वी में जो उसका वर्टेक्स में ऐसे उसी पॉइंट में डिफरेंशिएबल नहीं है, दैट पॉइंट्स आर नोन एज क्रिटिकल पॉइंट्स. सो फंक्शन के लिए मैक्सिमम और मिनिमम है तो क्रिटिकल पॉइंट में ही होगा. अंडरस्टूड? बट हियर मान लीजिए आपने इधर आपका पॉइंट मान लीजिए इधर तक द सपोज दिस इज योर बी, इधर तक द बी, सो क्या होता था इधर तक ग्राफ इधर तक आते हैं, so you can see that in this particular graph the maximum value, so the critical points are here, there are 3 critical points, one is here, another one is here, and here there are 3 critical points. The turning points, the one turning point here, second turning point here, third turning point here. So maximum और minimum है तो उधर ही होगा, but closed interval है तो we have to consider the end points also, क्योंकि कभी इधर आप देखो B में सबसे हाईएस्ट वैल्यू आ रहे, In B we are getting the highest value, and here we are getting the smallest value. So what we have to do is we have to find the, already हमें पता है कि maximum और minimum exist है, तो that will be at the critical point. So what we have to do is find critical points. Also include n points, क्योंकि हो सकता है n point में maximum होगा. There is a chance that n points में भी maximum है करके. So इधर particular example मैंने दिखाया B में in that closed interval AB, even though there are 3 critical points, here there is a local minimum, there is a local maximum here, and there is a local minimum here, but the function का maximum value आ रहा है B में सबसे highest value आ रहा है. So closed interval का case में the function may have a maximum, function will have a maximum value or minimum value at the points, critical points or the n points. So we have to find the points and we can check it. There is no need to apply derivative test. You can find the critical points, also include the points, include the n points. So you will get some points, and उस point में function का value निकाल लेना, and what is the maximum out of that points, the value which is the maximum value, that will be the maximum value, and which is the minimum value, that will be the minimum value. So we have to find the critical points. So f dash x is equal to 12 x cube minus 24 x square plus 24x minus 48. F dash x is equal to 0 implies you can take 12 common, x cube minus 2x square plus 2x minus 4 is equal to 0. Anyway, 12 cannot be 0. That means x cube minus 2x square plus 2x minus 4 is equal to 0. You can use the grouping technique. In the first term, you can take x square common from the first 2 terms, then remaining is x minus 2 plus next 2 term you can take 2 common, x minus 2 is equal to 0. So you can take x minus 2 common, x minus 2 into x square plus 2 is equal to 0. But x square plus 2 कभी भी 0 नहीं होगा. Therefore, x minus 2 is equal to 0. That means x is equal to 2. So now you got points. There is only one critical point, 2, but you have to include the n points also. So 0, 2, and 3. And find the function values f of x. Substitute it. When you put x is equal to 0, it is 25. Now, when you put x is equal to 2, that we have to substitute and find. Three into 2 to the power 4. 2 to the power 4 is 16. 16 into 3, 48. Minus 2 cube is 8. 8 into 8, 64. Plus 2 square is 4. 4 into 12, 48. Minus 48 into 2, 96. Plus 25. So 48 प्लस 48 96 माइनस 96 कैंसिल होगा 64 minus 64 plus 25, so it is minus 39. So 2 में वैल्यू मिला minus 39. Then 3 में वैल्यू 3 to the power 4 81 81 into 3, that is 243. 3 to the power 4 is 81. 81 into 3 243. 3 cube is 27. 27 into minus 8. 27 into minus 8 minus 216. 3 square is 9. 12 into 9 plus 108 minus 48 into 3, which is 144 plus 25. So you have to do the operation. 243 minus 216, which is 27. 27 plus 108, 135 minus 144, which is minus 9 plus 25, which is equal to 16. See, so the function will have a maximum value. So here, this is the maximum value that is actually occurred at the point end point 0 and minus 39. That is the minimum value. Understand? So the maximum or minimum that will exist at the critical points always. For any function, if there exists a maximum or minimum, कोई भी function के लिए maximum और minimum exist कर रहे हैं तो that will be at the critical points only. उसके अलावा कोई भी point में maximum और minimum exist नहीं करेगा, क्योंकि critical points मतलब जो point turning point होते हैं, जैसे U shaped, like open up और open down, जो भी, जैसे increase होके maximum आ गया then decrease हो गया, और then decrease होके minimum आ गया then increase हो गया, ऐसे. So otherwise V shaped graph, जो sharp edge जाएगा उस point में derivative different नहीं. That is why for any function, if there exists a maximum or minimum, that will be at the critical points. Critical points छोड़ के कोई भी point में function के लिए maximum और minimum नहीं होगा. And like a special case, continuous function in a closed interval. So a rough graph मैंने shown here. So closed interval में ऐसे रहते हैं कि जो हमने interval fix किया, so graph restricted हो गया from a particular place to another place, or from a particular point to another point. So उतना area में of course graph के लिए maximum भी होगा, minimum भी होगा. So there also we have to, maybe the maximum or minimum exists at the critical points, but we have to include the end points also, because maybe there's a chance that at the end point the function may have a minimum or maximum. So here हमने question दिया polynomial function. So this function we didn't check for the general nature. We have to, in a particular interval 0 to 3, उतना एरिया में फंक्शन का मैक्सिमम वैल्यू क्या है, मिनिमम वैल्यू क्या है. क्रिटिकल पॉइंट निकाला, हमें मिला क्रिटिकल पॉइंट 2. So then we add the end points 0 and 3, and all that 3 points. Here there is no need to check first derivative test, local maximum है क्या, local minimum है क्या, ऐसे देखने का कोई जरूरत ही नहीं, because we know that minimum और maximum एक्सिस करेंगे तो क्रिटिकल पॉइंट्स में होगा, नहीं तो एन पॉइंट्स में होगा. सो एन पॉइंट भी ऐड किया, क्रिटिकल पॉइंट भी ऐड किया, तीनों पॉइंट में फंक्शन का वैल्यूज निकाला. सो देखा उसमें से 25 मैक्सिमम वैल्यू एंड minus 39 minimum value. Understood? And what can you say about the shape of the graph, like general shape? सो रफ शेप में आपको दिखाता हूँ। देखो इसके लिए मैंने आपको बोला सिर्फ आपको चेक करना फर्स्ट टाइम 3x to the power 4, फर्स्ट टाइम ही चेक करना पोलिनोमियल फंक्शन फॉर फाइंडिंग द एंड बिहेवियर, not to draw the graph, to check the end behavior जब x is going to infinity where the function will go. So to check the end behavior we need to check only the first step. So when x is going to a very big positive number, a very big positive number to the power 4, 3x to the power 4, a very big positive number to the power 4, it's very big positive number into 3, it's a very big positive number, so it will go up only. Then बीच में ग्राफ कैसे भी आने दो, हमें पता नहीं, जो भी कैसे भी आने दो, लास्ट में we don't know the shape, and when x is going to minus infinity, देखो a very big negative number to the power 4, negative multiplied 4 times becomes positive, so very big negative number to the power 4 becomes a very big positive number only, into 3 it's again a very big positive number. तो बीच में शेप हमें पता नहीं, बट लास्ट में भी इधर ऑल्सो इट विल गो अप. So in reality, like not in particular interval 0 to 3, in general this function is having a minimum value exists. जनरल नेचर बता रहे आपका इंफॉर्मेशन के लिए, बट नो मैक्सिमम वैल्यू, बिकॉज दोनों साइड ग्राफ ऊपर जा रहे, सो मिनिमम वैल्यू नहीं है, बिकॉज एनीवे तो कोई तो एक मिनिमम वैल्यू तो होगा ही होगा, क्योंकि दोनों साइड ऊपर ही जा रहे, तो फंक्शन के लिए मिनिमम वैल्यू होगा. एंड कैन यू से व्हाट इज द मिनिमम वैल्यू? Not in the interval 0 to 3, for in general for this given function, can you say what is the minimum value? Anybody? This green one, I show you the general graph, like end behavior of the graph. When x is going to positive infinity, it will go up only. When x is going to negative infinity, then also it will go up only. So that means this function will not have a maximum value, but this function is having a minimum value, because दोनों साइड ऊपर जा रहे हैं, तो कम से कम इधर एक मिनिमम वैल्यू होगा ही होगा, क्योंकि नीचे नहीं जा रहे.
So 39 होगा.
Minus 39, that will be the minimum value, minus 39, because there is a critical point. So for maximum or minimum, it will be at the critical point. So we found the critical point, and there is only one critical point too. So function के लिए local maximum or local minimum है, तो that will be at that point only, and at that point we got the minimum value minus 39, and that is the minimum value of the function. उससे नीचे कभी नहीं आएगा, क्योंकि only one critical point. Okay, more than one critical point है तो उसी point में check करना पड़ता था, but ऐसे more than one critical point इधर नहीं, एक ही critical point है इधर 2, so minimum उसी point में है. So that means this function is having a minimum value, and that minimum value is minus 39 only. Not only between 0 and 3, everywhere. This in general, this function is having only one minimum value, means the minimum value is there. That minimum value is minus 39, and it occurs at the point 2. That's a general thing. But for our question was to find the maximum or minimum in between the interval 0 to 3. So we found the critical point, and we add the endpoints to it. So 3 points we got, 0, 2, 3. At that 3 points, we just found the value of the function, and we got the maximum and minimum from there. So in general, for a function, continuous function in a closed interval, continuous होना जरूरी है, नहीं तो हम नहीं बोल सकते theorem. For a continuous function in a closed interval, the function will have a maximum and minimum 100%. But in general, the function may have a maximum, may have a minimum, may have both maximum and minimum, and may not have maximum and minimum in general. But if you are discussing the function in a particular interval, closed interval AB, that means that A and B should be included, closed interval AB, then 100% there is one maximum value and there is one minimum value. Okay. आपने तो ओके 1 सेकेंड